Good morning. When we were distributing the topics, one of the topic was sleep. And nobody wanted to take that topic, so finally I landed up with taking that topic. But then I said there are two types of sleep: a feel good sleep and a feel bad sleep. That's why I'm going to take only the good aspect of sleep, the happy sleep. So we'll first speak about the feel good hormone, serotonin. Is the original happy hormone and is essential for mood, digestion, sleep, brain function, and circadian rhythm. Since serotonin is produced by the amino acid tryptophan, a diet of fiber-rich plant foods containing tryptophan will help increasing in serotonin. One of the example is banana. That's why people say eat banana in the evening and you get a good sleep. Prebiotics are some of the foods that promote the growth of beneficial gut bacteria. This has not to be confused with probiotics that are food which contain the bacteria. Here, prebiotics only promote the growth of beneficial bacteria. This is the amino acid tryptophan. If you add a hydroxyl group, it is called 5-hydroxytryptophan. And if you remove the acid component, it will form 5-hydroxytryptamine, which is serotonin. Serotonin is a rather elusive chemical. It is involved in everything, but responsible for nothing. It's something similar to a junior staff member involved in all activities, but responsible for nothing. The other hormone is dopamine, the motivational molecule. This chemical is a part of the brain's reward system. It is what gives you pleasure sensations and keeps you from coming back for more. That's why it's involved in addiction. Besides that, dopamine is involved in motor control and cognitive function, motivation and reward system of the brain, making decision making and impulse control, memory and attention. They're all the role of dopamine. This is the amino acid phenylalanine. If you hydroxylate the phenylalanine, hydroxyphenylalanine is also tyrosine, another amino acid. Add one more hydroxyl group, you get dihydroxyphenylalanine, abbreviated as DOPA, DOPA. And when you decarboxylate the DOPA, you get what is called as dopamine. That's how dopamine is produced. Dopamine is the active neurotransmitter in addictions to alcohol, to gambling, etc. The third feel-good hormone is endorphins, which is also called as a runner's high. Endorphins are hormones and neurosignaling molecules that function as painkillers. They inhibit the transmission of pain signals in the central nervous system by binding to opioid receptors. The ubiquitous runner's high, it can also be any exercise also, it not be only running, is caused by a big rush of endorphins. These endogenous secreting morphine analogs are of four types: endorphins, dynorphins, enkephalins, and endomorphins. Out of these, only three are important. The first three: endorphins, dynorphins, and enkephalins. The structure of endorphin, the beta endorphin, there are alpha and gamma varieties also, but out of them, beta endorphin is the most common. It's a 31 amino acid sequence. The gene for that is located in chromosome 2, short arm, second band, second region, third band, and third subband. Dynorphins are also dynorphin A and B. Dynorphin A is the more common one and important one. It consists of 13 amino acids. The gene is located in chromosome 20 at the terminal end of chromosome, short arm of the chromosome 20. First region, second band, second subband. And the third type, which we said is important, is enkephalin. There are two types of enkephalin, the metenkephalin and the leuencephalin, where the last amino acid, it's a 5 pentapeptide, which the last amino acid when it's metenkephalin, methionine, then it's called as metenkephalin, which is located on chromosome 8, long arm, second band, third to fourth subband. Oxytocin is also called as a cuddle hormone, a neurotransmitter that helps regulate stress responses and calms the nervous system. Oxytocin helps in human bonding, generosity, establishing trust, greater perceived love. So oxytocin is also called as a love hormone. The mood, summarizing these four hormones: serotonin, dopamine, endorphins, and oxytocin. Serotonin is a mood stabilizer responsible for well-being, happiness. Dopamine is a pleasure hormone, motivational role. Endorphins is a pain relief hormone, the runner's high. Oxytocin is bonding, love, and trust. Here we see a test tube. Dopamine high is schizophrenia. Dopamine low is anxiety and Parkinson's disease. So therefore, although dopamine is a hormone of addiction, it should not be too high and it gives rise to schizophrenia. It should not be too low and it gives rise to anxiety and Parkinson's disease. It should be just at the right balance. And for the addiction component, it requires a pulse of dopamine to be released and then quickly metabolized. Whereas a sustained high level of serotonin gives rise to the happiness. Dopamine, serotonin in low quantities give rise to depression. Serotonin, dopamine, oxytocin in high levels is responsible for happiness of love, whereas noradrenaline, adrenaline are responsible for the fright, fight, and flight reaction of autonomic nervous system. A good balance of dopamine, norepinephrine, and serotonin is required. Dopamine is a hormone of alertness in contrast to norepinephrine, which has got the primary action of concentration, and serotonin, the primary action is satisfaction. Dopamine and norepinephrine together are responsible for attention. Dopamine and serotonin are responsible for appetite. Norepinephrine and serotonin is responsible for endurance. Attention, appetite, endurance, all three put together gives rise to a balanced mood. The alertness of dopamine is responsible for clarity, motivation, and working memory. Decrease in level of dopamine gives rise to ambiguity, hyperexcitability, and passive memory. The concentration aspect of norepinephrine is responsible for certainty, determination, and recall memory, whereas reduction in norepinephrine gives rise to doubt, obsession, and dementia. The satisfaction of serotonin is responsible for relaxation, pleasure, and learning memory, whereas decrease in serotonin gives rise to insomnia, anxiety, disability, obsessive compulsive behavior, etc. We said oxytocin is a love hormone. The cuddling, snuggling, fondling, etc. increase serotonin and increase the love. When this chemistry changes to physics. It becomes euphoria. This activity, uh, when during euphoria, is helped by releasing of endorphins, and therefore the feel good factor, the euphoria, the painless state. The state can persist for a long time, but eventually you will reach a feeling that you feel. When you feel, you are going to feel a feeling that you have never felt before, which is called as ecstasy. It's at this point that a pulse of dopamine is released, and that's what gives rise to the person wanting to come back to more and more. Eventually, this will reach a stage of serenity whereby the person is calm. Then there are two options. Either he will proceed back to the cycle, or he will go out of the cycle and go to sleep. Sleep is a state of mind and body characterized by altered consciousness or characterized by unconsciousness from which a person can be aroused, in contrast to coma or anesthesia, where he is not easily aroused. The relatively inhibited sensory activity, uh, but it's the same sensory activity which wakes a person from sleep. The waking a person from sleep can be a loud sound, can be very bright light, can be a sense of touch, but usually sense of smell does not wake up a person from sleep, which is why there are people who have stayed in the house which is getting burned down, and then they die in the burning itself because that smoke smell did not arouse a person from his sleep, because smell does not arouse a person from sleep. There is reduced muscle activity, especially during the period of dreaming, what is called as REM sleep, the rapid eye movement sleep. There is inhibition of nearly all voluntary muscles, almost to the state of paralysis. The When the person is in a state of rest, the impulses from the surface of the scalp, you can record waves which are called as alpha waves. But when the eyes are open, the person is not awake, you get beta waves. And when the person is deep asleep, there are delta waves. So I always thought, where is the gamma waves gone? It's now found out that high impulses, extremely rapid acting, is gamma waves. This is when the brain is extremely active, great for learning, problem solving, etc. So alpha waves are 8 to 12 cycles per second, beta waves are 30 to 30, gamma waves are 31 to 120. When the person is about to sleep, stage 1, stage 2, there are theta waves secreted, which is slower cycle, higher amplitude, which is 4 to 7 cycles per second. The person is drowsing, drifting from into sleep and into dream, whereas deep sleep and non-dreaming is the delta waves, half to 3 cycles per second. Stages of sleep. Stage 1 of sleep is characterized by theta waves. It's also called as N1. Stage 2 of sleep have got sleep spindles with K complexes. These are theta waves which have got low amplitude sleep spindles with giant waves which are called K complexes. This is in N2 or stage 2 of sleep. N3 is the deepest sleep, which was originally subclassified into stage 3 and stage 4. In both cases, there are delta sleep. Interestingly, delta sleep is when we sleepwalk and sleep talk. So, somnambulism and somniloquy is most likely to occur. That's why it is said A person is fortunate when his wife and girlfriends have the same name, that when he talks in the sleep, he will only refer to the same name. Whereas there is another type of sleep which is called as REM sleep, rapid eye movement sleep, in which the sleeper's brain waves demonstrate a combination of alpha and beta that is almost similar to waking up. Here is a stage of sleep. From the awakened stage, the person is going into stage 1 of sleep. The period between awakening and stage 1 is called as sleep onset latency. Then he goes into stage 1, stage 2, stage 3, stage 4, which is called N1, N2, and stage 3 and 4 are together called as N3 because it is non-rapid eye movement. In between, after around 90 minutes or so, he comes into a short period of dream, REM sleep. And then again he goes back to sleep for a slightly similar duration, but he comes to a larger component of dream sleep. In the end of the dream sleep, you also sometimes awaken in the night and then go back to sleep, dreaming. The dream sleep duration initially is around 10 minutes. Later on, it increases. Together, it accounts for approximately 25% of the sleep. So, if you are sleeping for 8 hours, you will be dreaming for 2 hours. If you sleep for 7 hours, you will be dreaming lesser. That's why it said, dream big, achieve big, sleep well. And if you notice, towards the later part of the sleep, the slow wave sleep is not there at all. It is a little shallower sleep because you can easily be awakened from that point of time. The sleep is to maintain homeostasis. Most of the body systems are in anabolic state. Adenosine is phosphorylated to ATP, which is the energy molecule. So as the day progresses, the ATP is converted to ADP, which is then converted to AMP, and finally only adenosine. That's the time when the person has least energy and prefers to go to sleep. Sleep helps in restore the immune function, the nervous system, the skeletal muscle, the muscular system. They are vital processes that maintain mood, memory, and cognitive function. Physical rest and but sleep deprivation will have an effect on body and brain. But if you just have physical rest without sleep, it does not affect exercise, it does not affect stress response. So, whereas physical activity, but sleep deprived brain does affect the mood and does affect cognitive function. So, when we say body except brain, we are also referring to spinal cord because a high transaction of the cervical spinal cord results in the lower part of the spinal cord never going to sleep. Brain requires sleep, otherwise it changes the mood and cognitive function. The sleep is produced by brain waves, brain centers. So that's why it is said that although physical rest is sufficient for the body, the function of the sleep is it's a function of the brain, by the brain, for the brain. The mechanism of sleep or circadian rhythm is entrainable endogenous biological activity that has a period of roughly 24 hours. Here, the internal time-giving mechanism is centralized by suprachiasmatic nucleus in the humans. It allows for internal physiological mechanism underlying sleep and alertness. Another chemical which is released at the time of sleep is melatonin. So the sleep neurotransmitters for the awakening state is glutamate, acetylcholine, dopamine, noradrenaline, serotonin, histamine, orexin, also called as hypocretin. For the deep sleep, it is GABA, ghrelin, adenosine, melatonin. Notice GABA is there in both all the phases, but the activity of GABA is relatively reduced in awakening state and the activity of glutamate, the excitatory neurotransmitter, is decreased in deep sleep. Acetylcholine comes back to the stage of dreams, where also glutamate and GABA both are there. There is glycine which is secreted during dreams. This is responsible. This is what the Renshaw cells in the spinal cord, which are inhibitory to the muscle tone and muscle activity. Talk about the key neurotransmitter which was labeled as red in the earlier one. Serotonin does not help in direct sleeping action, but it decreases the sleep onset latency. So you can quickly go to sleep during serotonin, but otherwise serotonin activity will awaken the person. Orexin is a neuropeptide that regulates arousal, wakefulness, and appetite. We said that orexin, orexia, appetite, but it is also a very important neuropeptide for arousal and wakefulness. Galanin is a peptide which modulates the action of classical neurotransmitters. It inhibits the secretion of pancreatic hormones and stimulates the release of growth hormone and prolactin. And melatonin is involved in synchronizing circadian rhythm. Melatonin is secreted when there is decreased light, and we already said glycine is responsible for the muscle atonia and muscle almost paralysis in REM type of sleep. We have already seen how serotonin is produced. When serotonin is acetylated, it gives rise to acetyl hydroxytryptamine, and then when it's methylated, you get N-acetyl 5-methoxytryptamine, which is also called as melatonin. Which is why that serotonin levels are extremely high in pineal gland, which is responsible for secretion of melatonin. Melatonin is a ubiquitous molecule with natural, powerful antioxidant properties. It also exerts an anti-inflammatory effects and anti-apoptotic activities. Here is a cycle with the lower part showing midnight. You can see the sunrise in the early morning and sunset in the late evening. This cycle has been slightly tilted to the right because this is specifically meant for Mumbai, where the sun rises 1 hour later than Calcutta. Melatonin secretion starts at 9 o'clock, that is 2 to 3 hours after dark, and then it stops when there is light. The changes in the sleep are because of melatonin secretion and stopping. The deepest sleep is midway between 9 o'clock and 7 o'clock, that's around 2 o'clock or so. Peribrachial area of the pons, around the region of brachium pontis, is the one which is called as the center of REM sleep. The peribrachial area sends information to tectum, and the tectum is responsible for the rapid eye movement. How rapid is rapid? The eyes move side to side, and there are around 7 cycles which are completed in 1 minute. That means it takes around 8 seconds for the eye to complete 1 cycle, which means the eyes are not really moving as fast as it is when you are awake, but still it is much faster than when you are deep sleep. Peribrachial area also sends information to basal forebrain and thalamus, which is responsible for the cortical desynchronization. That's why the waves are alpha or beta during dreams. Peribrachial area also sends information to magnocellular nucleus of the medulla oblongata, which sends glycine to the skeletal muscle, which is responsible for the near state of paralysis and atonia in the muscle during dreams. Sleep disorders, disease flare, pruritus, scratching, melatonin dysregulation are the two components which disturb sleep, which are treatable by exogenous melatonin. Remember, we said melatonin is anti-inflammatory, So the itching, scratching, etc., which can also be blocked by antihistaminics. But melatonin will be helpful in sleep as well. Environmental factors towards the left, what we are seeing, allergens, light, etc., disturb sleep. The dust might control in bedroom. Avoid mobile phone, laptop, desktop, and other electronic gadgets just before bedtime. And provide a dark sleeping environment because otherwise melatonin will not be secreted. Circadian rhythm of the skin, the transepithelial water loss, and the skin blood flow should be controlled by topical steroids in the evening. Cytokine dysregulation are what is seen in inflammatory, interleukin 4, gamma, 31, etc. These are responsible for disturbance of sleep. Sleep hygiene can be improved by itself by exogenous melatonin and first generation antihistaminics, benzodiazepines, and clonidine, which are all responsible for improving sleep. What will happen if there is decreased sleep? There will be memory issues, there will be trouble with thinking and concentration, there will be mood changes, and all these things will result in accidents. Besides that, deprived sleep releases ghrelin, hunger hormone from the stomach, and decreased sleep will give us to decreased peptide YY, which is the satiety hormone. Ghrelin says, I should eat, I am hungry. And peptide YY says, hey, I am full, I have had enough to eat. But if you have a sleep deprived, you tend to feel more hungry, then you go in for binge eating. And binge eating will result in weakened immunity, high blood pressure, risk for diabetes, weight gain, and risk for heart disease. Sleep disorders can be classified as dysomnias, which are either decreased sleep, insomnia, excessive sleep, hypersomnia, narcolepsy, a specialized type of disorder which results because of sleep deprivation, and excessive sleep during the day, and sleep apnea, a short breath holding spell during sleep. Parasomnias are somnambulism, walking, sleep related eating disorder. We said about the binge eating, sleep enuresis, usually normal till the age of 6, but beyond that, all the first three parasomnias occur during deep sleep, whereas during the dreams, there is something called as REM, behavioral disorder, which is also called as RBD. Here, the person is actually acting out his dreams. So, normally we said REM is responsible for almost muscle atonia and paralysis. But here, the person is actually acting out the sleep. And sometimes there can be violent movements during this, which can hurt the person himself or the bed partner. Bruxism is teeth grinding during sleep, and circadian rhythm disorders. We have heard of people like early birds who wake up in the morning and are they can concentrate and study. Where there are some people who study at night. They are called night owls. Both these are, if they are within normal limits, that's normal. But if they are excessively departed from the normal, then it's called circadian rhythm disorders. The cycle of sleep and waking is specifically by GABA. So GABA, which is shown in red color, keeps on inhibiting the ascending reticular activating system, which is shown in green color, and inhibits orexin, which is responsible for arousal. The inhibitors of arousal system includes H1 antagonists, H3 agonists, alpha 2 agonists, and muscarinic antagonists. So these are responsible for sleep, whereas potentiators of GABA inhibition, benzodiazepines, barbiturates, ethanol, chlorhydrate. These are all responsible for GABA mediated sleep. The other one is responsible for excluding GABA related sleep. Sedatives and hypnotics. Benzodiazepines are the most widely used anxiolytic and hypnotic drugs. They have largely replaced barbiturates and methylphenidate as a tranquilizer. However, benzodiazepines disturb intellectual memory, affect motor dexterity, etc. So, to avoid the side effects of barbiturate, avoid the side effects of benzodiazepine, you should take intermediate acting or short acting benzodiazepines so that you don't get sleepiness in the daytime. How do benzodiazepines help? They attach to the GABA receptors, but not at the site where GABA is attaching. When GABA gets attached, they enhance the chloride intake into the cell. So binding of GABA is enhanced by benzodiazepine, resulting in greater entry of chloride ion. Entry of chloride ion hyperpolarizes the cell, makes it difficult to depolarize, and therefore reduces the neural excitability. In contrast, barbiturate also attach to these receptors but do not require GABA. They can themselves open up the chloride channel and cause hyperpolarization. So here we have an example of drug A and drug B. If you notice, as the dose increases in drug A, the person goes from sedation to hypnosis. Hypnosis is the god of sleep. Hypnosis, anesthesia, coma, and finally it goes to respiratory paralysis and death. So if you notice drug A, if you take one tablet for sleep, hypnosis, two tablets you will reach into anesthesia or coma. More than two tablets can result in death. This is an example of barbiturate. Why they are now no longer used for sleep. There's the ultra short acting is also still used for anesthesia, where they are properly titrated so the person does not reach the stage of coma or respiratory paralysis. In contrast, drugs B, which is shown here, at low levels causes sedation, higher levels causes hypnosis, but then as the dose increases further, they don't reach coma as fast. In fact, reaching anesthesia itself is difficult. This is an example of benzodiazepines. In fact, it is said you require around 500 tablets of benzodiazepines, where one tablet causes hypnosis, two tablets causes hypnosis, 500 tablets is required for death, which is practically impossible. But there are alternatives to benzodiazepines, antidepressants with anxiolytic effects, such as selective serotonin reuptake inhibitors. Here, serotonin is metabolized by its reuptake, but if it is not reuptaken, serotonin levels helps in facilitating the person going into sleep. First generation antihistaminics are also sedatives. The newer antihistaminics are the ones which are non-sedative. There are non-benzodiazepine hypnotics, which are not benzodiazepine structurally, molecularly, but they still act on benzodiazepine receptors. And then there is ramelteon, which is a melatonin agonist. So they help in the additional support for person wanting to go to sleep. The point to be noted, as a sedative and anxiolytic activity, benzodiazepines are the best. But for hypnotics, we have these alternatives. CNS stimulants. So when a person is oversleeping, he requires CNS stimulants. Caffeine blocks the adenosine receptors. We said when ATP is converted to ADP, which is then converted to AMP and finally adenosine. It's adenosine which causes sleep. Caffeine blocks the adenosine receptors, so adenosine cannot act. That's why it keeps a person awake. For people who are finding it difficult to sleep, should not take caffeine after 12 noon. In low doses, nicotine, which is seen in cigarette smoke, causes CNS euphoria. But at high doses, the same nicotine blocks the receptors. So that causes depression. Or you require exogenous nicotine again further. Cocaine, the drug of abuse, blocks the reuptake of monoamines. So when monoamines are not reuptaken into the presynaptic terminus, they remain in the synaptic cleft for a longer time, which arouses the person, keeps the person awake. Amphetamine, which is the one which clearly enters the brain, releases the intracellular source of amphetamine. Amphetamine also inhibits monoamino oxidase, and therefore, and it itself acts as a weak stimulation of the nerve endings. Amphetamine is a drug of abuse. It causes a person to go into so much of euphoria, so much of happiness, so much of excitability that he cannot go to sleep. There are people, because this drug is available over the counter, people take amphetamine one day before their exams, study the whole night, and they're so excited that when they have reached the exam site, they are feeling sleepy. So to counter that, they take one more amphetamine and write the paper. They're so much excited after writing the paper, but then we say, keep one more amphetamine with you because you will require that when you are seeing your results. You have not studied, you don't remember what you have studied, you don't know what you have written. And then, of course, you'll be shocked by the amphetamines were formerly used for attention deficit hyperactive disorder and narcolepsy in individuals. But then they found another substance called methylphenidate, which is similar to cocaine, blocks the uptake of monoamines. And because enters the brain much more slowly, it is preferred over cocaine for attention deficit hyperactive disorder. In attention deficit children, what happens is that dopamine is not adequately stimulated, so they get bored very easily, and therefore they are hyperactive. They can't concentrate on one thing at a time, and therefore they are poor in studies as well. So here, because of the decreasing the reuptake of the dopamine remains for a slightly longer time. Attention deficit is improved, automatically the hyperactive also goes down. Modafinil, whose action is not known, is considered the first line agent for narcolepsy because of the side effects of amphetamine, which modafinil does not have. What is narcolepsy? It's characterized by difficult sustaining wakefulness, poor regulation of REM sleep, and disturbed nocturnal sleep. All patients with narcolepsy have excessive daytime sleepiness. Narcolepsy can be accompanied by sudden loss of muscle tone, cataplexy, which can be triggered by strong emotion. So, you look at the hypnogram of a person who is healthy, he'll have a continuous 8 hours of sleep and rest of the time is awake. Whereas in the next lower half, you see a narcoleptic patient who is sleeping early, sleeping almost throughout the day, and in between is interrupted by REM sleep. So what happens is you might find a person who is cracking a joke, laughs at the joke, and suddenly goes into REM sleep, muscle atonia, muscle paralysis, he collapses. That is cataplexy. So narcolepsy and falling down is cataplexy. Modafinil, we said, is the first drug of choice for keeping the person awake. Selective serotonin reuptake inhibitors or serotonin norepinephrine, they also help in suppressing the REM sleep. We said serotonin norepinephrine is not secreted during REM. So that REM cataplexy is relieved by, and then there are, for the person to sleep properly during the night, you can give gamma aminobutyric acid substitutes. So stimulants to keep the person awake, serotonin or epinephrine to suppress the REM sleep, and therefore the person doesn't collapse into atonia, and GABA so that the person sleeps in the correct time. With that, we come to the end of the discussion.